Is convert an explicit formula to a recursive formula. This is the topic for today. Last time we did the inverse. We worked with the recursive formula to convert to an explicit formula, but today is inverse. So now we are going to find the recursive formula, starting with the explicit formula. So this topic belongs to Algebra1. Some idea, just background. An explicit formula defines a sequence using only the index n, right? And the recursive formula defines a sequences using earliest terms. Okay, we have a problem here. You see this problem. The recursive formula should depend on an equals an minus 1, right? So an equals, this is the explicit formula, an is equals minus 17n plus 39. This is the explicit formula. We have to find the recursive formula, right? Use the explicit formula to find the first few terms of these sequences. Okay, starting with n equals 1, right? And then plug in the explicit formula. Plug in the explicit formula right here. If you do that, we are gonna have for example here we are gonna substitute first. So we are gonna have a1 right here equals negative 17, right? Times 1 plus 39, right? How much is this? It's negative 17 plus 39. It's gonna be 22, right? Yeah, 22. Just find the first few terms, okay? The first few terms of the sequences, starting with 1. So next, we have to find find a2. So a2 is you substitute right here. So plug in n2 in the explicit formula. You're gonna have minus 17 times 2 plus 39. How much is it? So it's gonna be 2 times 34, right? Yeah, 34, negative 24, 34, negative 24, negative 17 times 2 is negative 34, plus 39 is equals 5, right? Now, from here, I think this time to make a little table. You do a table right here, so to put all numbers, you must to continue these sequences, n3, n4, n5, n6, at least write six numbers. But first we're gonna do the table right here. Some table that's very important. Make the table right here for you guys. An right here, and then here should be an minus 1, right? Just some ideas. So write the numbers where we did number one right here is 22, right? Number two is number 2 is 5. If you continue doing number 3 is negative 12. Just let's go doing number 4 must be negative 29. Number 5 is negative 46, and then number 6 is negative 63, right? Well, what do you see here? So you see here, this is the first term, but the first term you see here is what is the space, the sequences. And number 5 here is negative 15. See, negative 15. So down. So here is the space is negative 15. From 5 to negative 12. See, negative 12 in the number line, negative 12, see what is negative 12, and then move it to positive 5. You have negative, right here, negative is negative 17 too, right? From 12 to 29, negative, so it's going to be also 17, right? See, from 29 through negative 46 is negative 17 too. And then same thing here is negative 70. So you have this table. So what show this table? This table show I'm gonna write right here. So this is gonna be 8. This table, okay, in the table, and minus an, right? Minus 1 equals negative 70, right? The table 4, 2, yeah, 2 minus equals n, and minus equals 6. Right there, the space right here. See, this number is very important. Okay, in the table you see this. All right, so next step, for example, if here we need to find the recursive formula. So right now we substitute the explicit formula. To continue this process, the first 6 terminals, your first few terminals on the sequence satisfies the first 6 terms, and the recursive formula so satisfies and the explicit formula satisfies the recursive formula. What is the recursive formula? So right here, I write it right here. Okay, see, to verify, so now we have to verify that this formula, okay, this formula works for any n right here, any n, or the numbers that we give it, this any n right here, this process, and then substitute the given explicit. So we have to substitute into the recursive formula. So what is the explicit formula? The explicit formula is this one, an right here, an, whereas equals negative negative 17, right? 17 plus 39, right? Okay, into the recursive formula, right? Into the recursive formula. So let's write a little bit into recursive formula. Okay, into the recursive formula. So now to do that, we are going to have, look at this. We're going to have an right here, an. Look at, listen to me right here. An equals an minus 1 minus 70. Okay, minus 70 right here. Okay, so go in this way. Next step, write negative 17 right here, negative 17 and plus 39. This negative 17 plus 39 equals maybe, so bracket, right, bracket is minus 17 times n minus 1 plus 39, right? Close bracket, minus 17. All right? I'm gonna write the signs with different color right here. Sometimes we confuse. Okay, all right. So it's in the middle. Okay, next step. Write down again this negative 17n plus 39 seem equivalent to here now. When you multiply this, we are gonna have right here. How much? We are gonna have 17n, right? Yeah, 17n. 17n plus 17 plus 39 minus 17. So without brackets. Okay? Now, next step. Right, again, in the first, the left side, negative 17n plus 39 equivalent to, now, negative 17 right here, negative 17n plus 39. Right? Negative 17n plus 39. Oh, right here is negative. Negative, okay, it's negative. Yeah. Negative times positive is negative. Negative 7n plus 17. Negative times negative is positive 17 right here. So 17 plus 39 minus 17. Okay, right. Now, next step. The formula. What is the formula? What is the formula? The formula is right here. Remember, the formula is, what is the formula? Is an n, right, equals an minus 1 minus 17. This is the formula, right? So, satisfy by sequences, right here, satisfy by sequences. We're talking about the sequences. Right here, an, right, equals negative 17n plus 39, right? So, the recursive formula then, now by conclusion, the recursive formula, because we are looking for the recursive formula, the recursive formula, what is the recursive formula now then? So an, right, equals an minus 1 minus 70, right? This is the recursive formula, right? Right there you have the answer. So here, just write it, because we are looking for the recursive formula. The recursive formula is going to be an right here, whereas minus 1 minus 70. This is the recursive. The first one is explicit formula. So see, we make a table. Now see the process. We started with a few terminals in the sequence, and for example, give it numbers right here. And 1, and 2, and 3, and 4, and 5, and 6, and that's it. So that's enough. With 6 times enough to find the recursive formula, and then now substitute in the explicit formula, in the recursive formula right here, the explicit recursive formula, substitute right here, and then you can find the recursive formula.